Welcome to Get Your FRQ On. This question is from 2007, Form B. It's question 6, and it is not calculator active. In the question stem, we have f as a twice differentiable function, and we are given that f of 2 is equal to 5, f of 5 is equal to 2, and g is the function defined by f of x. In part A of this question, we are asked to explain why there must be a value of c between 2 and 5, such that f prime of c is equal to -1. In the question stem, we are told that f of x is twice differentiable. This implies that f of x is also continuous. So if we calculate f of 5 minus f of 2 all over 5 minus 2, we get 2 minus 5 over 3. That's -3 over 3, and that is, of course, equal to -1. Therefore, there must be a value of c between 2 and 5 such that f prime of c is equal to -1. This is an application of the mean value theorem, although you never have to state that. You just have to verify that the conditions of the theorem are met and show that the conclusion actually does follow. In part B of this question, we are asked to show that g prime of 2 equals g prime of 5, and to show that there is a value of k between 2 and 5, such that g double prime of k is equal to 0. G of x equals f of x implies that the derivative of g is f prime of f of x times f prime of x. So if we calculate g prime of 2, that's f prime of f of 2 times f prime of 2, which is f prime of 5, times f prime of 2. And if we calculate g prime of 5, that's f prime at f of 5 times f prime of 5, which is f prime of 2 times f prime of 5. And since multiplication is commutative, those are exactly going to be the same. And since f is twice differentiable, g must also be at least once differentiable. And since g prime of 5 and g prime of 2 are equal, g prime of 5 minus g prime of 2 over 5 minus 2 would equal 0. Therefore, there must be a value of k between 2 and 5, such that g double prime of k is equal to 0. In part C of this question, show that if f double prime of x is equal to 0 for all x, has no points of inflection. So this explanation might seem a little tricky at first, but when you hear it and you follow along, it will start to make a lot more sense. So we're going to begin by assuming that f double prime of x is 0 for all x. And notice that this implies that the first derivative of f must be a constant for all x. For some constant c, it doesn't really matter what it is, it has to be a constant. Well, if that's the case, and f prime of x is equal to c for all x, that would imply that f of x is that constant times x for all x. And if f of x is equal to a constant times x for all x, this implies that f of x is a linear function. And if f is a linear function, then g of x equals the composition of f with itself would also have to be a linear function. And if g of x is a linear function, then g of x cannot have any points of inflection. In part D of this question, we define h of x to be the function f of x minus x. And then we are asked to explain why h of r must equal 0 for some value of r between 2 and 5. In the question stem, we're given that f is twice differentiable, which implies that f is continuous. The function y equals x is a polynomial, so y equals x is also continuous. Now, since f of x is continuous and y equals x is continuous, this implies that h of x equals f of x minus x is also continuous. Evaluating h of 2, we get f of 2 minus 2, which is 5 minus 2, that's 3. Evaluating h of 5, we get f of 5 minus 5, which is 2 minus 5, which is negative 3. So h of 2 is positive 3, h of 5 is negative 3. Since 0 is between h of 5 and h of 2, since h of 5 is negative 3 and h of 2 is 3, 0 is definitely between those two numbers. And therefore, we can conclude that h of r must equal 0 for some value of r between 2 and 5. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.